Good day, class, and welcome back to my calculus class. Right now, we are going to be looking at graphs of sine and cosine functions. We have seen sines and cosines of angles in different forms. So we want to look into their graphs. So we will be looking at the variations of sine x and cosine of x, that is sine and cosine of angles. We will also be looking at their transformations. Let us start by just graphing the function y equals to sine of x, just this. Now, we do know that if our input are the special angles 0, pi over 6, pi over 4, pi over 3, pi over 2, and so on, up to we get to one full revolution or one full rotation. Say something like this. We are back to our unit cycle again so we have pi over 6, pi over 4, pi over 3, up to pi over 2. So we do that up to this place and also to pi and to 3 pi over 2 and back to 2 pi until we have one rotation. So let us see from the table we do have here. When x is 0, sine of 0 is 0. We do know that also from unit cycle. When x is pi over 6, that is when our angle is pi over 6, the y value is 1/2. When it is pi over 4, it is root 2 over 2. When it is pi over 3, it is root 3 over 2. When our input is pi over 2, the output is 1 for sine. And when it is 2 pi over 3, we have this. The next one is here. We have here, and when it is pi, it is 0. Then, now we move to the second quadrant. This is the first quadrant. We see what is happening here. This is the first quadrant. See, when angle is 0, the y value is 0. When the angle is pi over 6, the y value is 1 over 2, and so on, until we get to 90. At 90 here, that is when we have the highest value, which is 1 for y here. And now this side is in the second quadrant. So we can see, and at pi, it is back to 0. That is why at this point, we do have -1, 0. So the y value there is 0. So we do have the first two quadrants up here. Now, let us go to the third quadrant. Then we see that for 7 pi over 6, that is when our angle is 210 degrees, then it is -1/2. Here it is -root 2 over 2. For 4 pi over 3, we have -root 3 over 2. And next, when it is -3 pi over 2, that is here, at this point, that is where we have 3 pi over 2. So when it is 3 pi over 2, our y value is -1, right? That is 0, -1 for y. Moving on, at 5 pi over 3, it is -root 3 over 2, and so on until we get to 2 pi, which is 0. Now, what we do have here is in the third and in the fourth quadrant. So let us see what we have. If I grab this, I will have, like, if I join everything together, then I will have something like this. Keep going. Okay, we have this, and we call this graph the graph of sine x. The graph of sine x. Can see? Very beautiful. And a couple of things to learn here. What we do have here is one full rotation for sine angle of x. One full rotation. So we see up here we have up to this point. This is our first quadrant. Let me just call it Q1. Here, Q2. And here, Q3. And this place, Q4. And we are back. Now, let us move on. Let us move on. I will be making reference to this graph. Now, using that table, we have something like this that I just grabbed. Here, from here up to these points. Now, what if I move in clockwise direction? Remember, this part is counterclockwise, the way we should move for positive angles. Now, for negative angles, I need to move in clockwise direction. And we have this side. We have this side from, I'm going to change this. So we have from here, then it behaves this way. So nothing fancy there at all. There is one thing we notice here. We observe that sine function, again, as we have learned before, is an odd function. Or we say the odd symmetry of the sine function. If you look at this, we can see it is symmetrical about the origin. It is symmetrical about the origin. If I take this head here, if I take this end and I just move it, I will have exactly what I have in red here. Just take, if I take this head, this end point, if I take it and I move it about the origin, then you will see I will have exactly that graph in red. So we say the sine function is symmetrical about the origin, or we say it is an odd function. Okay. If we do the same thing for cosine, then we are going to have this graph. So from that point up to this, we have one full rotation for when we move in counterclockwise. We have one full rotation. And when we move in clockwise, that is, for our negative angles, then we have one full rotation here. Now, again, we observe that this cosine function is symmetrical about the y-axis. That is, if I just do this, I have the same thing. Look at it. If I take this endpoint and I just move it this way, moving about that y, then I will have the same thing. So cosine function is an even function. It is symmetrical about that y-axis. All right. Now, we say sine and cosine functions are examples of periodic functions. What do we mean by the word periodic? A periodic function is a function for which a specific horizontal shift, let's call it P, a value P, results in a function equal to the original function. Let me break that down for us. We are saying that there is some value such that if I add that value, call it P, to the input value to X, then I'm going to have exactly that function again. Let us go back to the sine function. Now, if you notice that every other angle from here onward, every angle I have from here onward, what I'm going to have now is, again, situation like this. I'm going to have situations like this. I'm going to be having situations like this. That is what I'm going to be having, and so on, like this. So again, I will have this. And so on. Now you would notice that, well, we are just repeating. We are just repeating what we have in this first and second quadrant. We are just repeating it. We are just repeating it, just like we have learned in the past. Once you complete that one cycle, then we are just doing the same thing, right? Okay. So that is what we are saying. Then we say, oh, from this great observation, then we can say sine and cosine are periodic functions. Now, there is a least value that will make that to happen, a least value for this p, such that we will always get our function back. That is, suppose I have something like this. That is one rotation. Then I go again. That is another rotation. Let me change my pen to something like this. Then I go again. That is another rotation. You see, I'm just repeating the same thing. I'm repeating the same thing. So we say it is periodic. Now, I just explained all these. Right. So this is one period. Now we call this one period. Now from here up to we go for sine function that will complete one rotation. Then we say that is one period. For cosine as well, we start from here and we move this way up to this point. Then we say that is one period. Now what we notice is that sine and cosine functions are periodic with a period of 2 pi. With my explanation, you will now see that when we have one complete rotation, if I start again and I move, that is another 2 pi. That is another 2 pi. That is another 2 pi. So we say that the period of a sine and cosine function is 2 pi. The domain of each function, that is sine and cosine, is from negative infinity to infinity, the domain, right? However, the range is just from negative 1 to 1. Negative 1 to 1. You can see from unit circle, we have that negative 1 to 1, or from here, you can see that is the range from negative 1 to 1. Okay, let us continue our study. Now we give these kind of functions a special name. We call them sinusoidal functions. Sinusoidal functions. A function that has the same general shape as a sine and cosine function is called a sinusoidal function. And the general forms of sinusoidal functions are given as this. Let us see. I have y equals to a sine b x minus c plus d. We will break it down. What is a? What is b? What is c? What is d? We will break it down. We will learn it. So a sine or a cosine, we have the same representation, general form. In general, in the general form, b, that is the term b, is related to the period by P equals to 2 pi over absolute value of B. What is a period of sinusoidal function? We say this period of a sinusoidal function is the smallest positive value for which the function's values repeat at regular interval. That we now know very well. We explained that. Okay. Now we are saying that the B that we have here is related to the period by 2 pi divided by absolute value of B. We will need this as we continue. Just keep this for now. Just to know that there is a relationship between period and that B. Now let us study this. When that absolute value of B is greater than 1, what do you think? I'm dividing 2 pi by a number that is greater than 1, let's say 1.5, for example. What do you think? This whole number will become smaller because I'm dividing by something that is bigger than 1. So the OP here, the OP, that is the O period, will become smaller. Say I'm dividing 2 pi by 1.8, or I'm dividing it by 5. This whole thing will be becoming smaller and smaller. If I'm dividing by something bigger than 1, then we say there is horizontal compression. Because now the period is less than 2 pi. Because we are dividing by something that is more than 1, it is shrinking the 2 pi. It is making the whole thing now become smaller. And remember, what we are shrinking is P, the period itself. So the period is becoming smaller. So we say we have horizontal compression. In a visual way, we are saying that instead of one rotation to be from 0 to end at 2, to end at 2 pi, then we are shrinking it. It is no longer 2 pi. It is something less than 2 pi to complete that one rotation. It completes the one rotation, but it doesn't get to 2 pi. Don't get confused. But teacher, you said sine function and cosine function, they have period of 2 pi. Yes, nothing has changed. I am just saying we are now looking at variations of sine and cosine functions that we call sinusoidal function. Just like if I have x squared, I can multiply it by this. I can subtract something from it. In fact, I can have something like this. These are variations of x squared. The same thing we are doing here. Okay. Let us go back to our study of sinusoidal function. Now you are already thinking, what if the absolute value of B is less than 1? Now, if that positive number is less than 1, then you see that the period itself becomes bigger. So we say there is horizontal stretch because the period is greater. And if B is 1, then we just have what? We have the period to be 2 pi. We have the period to be 2 pi. Look at it. If B here is 1, if B is 1 here, then we just have y equals to a sine. So we just have x minus c plus d. So you can see what we have there, just x, sine of x. Let us keep developing this idea. So consider the graph below. Let us see, just like I just walked you through it. Look at the guy in, is this red, or I will call it red, maybe not completely red, orange, is it? Okay. This guy, this graph. Now you see moving this way, and you see getting back to pi and completing one full rotation at 2 pi. Then you see it is what? Sine of x. In that case, our b is 1. Our b is 1 in that situation. Now, look at another situation whereby um whereby what can I do? I can let us study this. Now, look at it. We complete one full rotation here, right? We complete one full rotation here. You can see. The question is, why is that? Why is that? Then, see, that is because our B is bigger than 1. And what do we say? Let us revisit that. P equals to 2 pi divided by B, absolute value of B. Now, because our B is bigger now, let us see our period for that particular function is, our B is 2, so that is pi. Meaning that the function is going to be completing one rotation within pi. I hope that is making sense. So the function will be completing one rotation, the entire rotation in 1 pi. Now you can see that we have it again. So by the time it's getting to 2 pi, it is already completing 2 rotations. Because now the period is smaller. So it completes one rotation faster than when B is less than, when B is equal to 1. Let us just talk about that. Now let us look at this over here. I will again clear this. Now, in this case, our B is 1/2. Our B is 1/2 because I can write it as sine f of x equals to sine of 1/2 x, right? So B in this case is 1/2. Now, again, let us see. Our P is related to B by 2 pi over absolute value of B. Now, B is 1/2. And now, if you do the arithmetic, we have 4 pi. Meaning that our period is now 4 pi for that function. And what that means is that it will complete one rotation in 4 pi. Instead of 2 pi, it will take it 4 pi. Now look at what we have when we graph it. Then look at it. By the time it is getting to 2 pi, it has just completed half. So now to complete it, it has to go this way up to 4 pi. That is when it will complete one rotation for that particular function. And that agrees with what we studied because the B is less than 1. The B is smaller now. Now, when you are dividing 2 pi by a very small number, then the period itself becomes bigger. That is, it takes a longer time for the function to complete one rotation. I hope that makes sense. Let us keep studying. Let us keep studying. From example 1, equation 1, remember? Equation 1 is y equals to a sine or cosine, whatever the case is, bx minus c plus d. Now, from this equation 1, if we set c to be 0 and d to be 0, let us see a special case. That is, let us forget about c for now and d for now. So we will have a sine or a cosine bx. That is what we would have. That is a sine bx, a cosine bx. And the period is 2 pi over b. Let us take example. Determine the period of the function f of x equals to sine pi over 6x. We would see that in that case, this guy here is b. That is, b equals to pi over 6. Now, we remember that period is related to b by 2 pi over absolute value of b. Absolute value of pi over 6 is pi over 6. So we have 2 pi divided by pi over 6. And we do have 2 pi times 6 over pi. So we can have pi here 1, pi here 1. So we do have that the period is 12. That is the period for that function. So we see the period is very big now, 12. Okay. I will just leave you with this. This is simple. I will leave you with this to figure out the period. The question is saying find the period for this function. So just pause this video and find the period of that function. The next thing we will look at is finding the amplitude. Let us talk about the amplitude. So we return to equation 2, this equation 2. We've talked about B, now let us talk about A, amplitude. From your study of quadratic, if you have something of this nature, x squared, what happens if you have something like this, 2? What happens? Remember, if x is, for example, 1, if you square 1, you have 1. If you multiply by 2, the y value becomes 2. If your x is 2, you square it, you have 4. If you multiply by 2, you have 8. Now, if you compare it to when you have just x squared, you will see you are magnifying your y value. The same thing is happening here with this a. We are magnifying the y value by having this a here. So we call it amplitude. Amplitude for sinusoidal functions. So let us study that. Again, the absolute value of a is called the amplitude or greatest distance from rest. That is, we call it vertical stretch factor. What do we mean by rest? If we have our let's see, if we have our function this way, let's say a typical sine function. Now, this point is called the rest. This point, this line is rest. Now we say amplitude is the distance from rest. Now, this is the highest point here. So we say that is the amplitude, the distance from rest. We are considering the absolute value because you can see that we can also consider this point, right? So I will return to how we find the amplitude. The local maxima will be a distance above the horizontal line that I just showed you, the local maxima, which is the line y equals to d. That is, we call this rest line y equals to d. In fact, we have introduced d, but I will not talk about it for now. In this case, because d is 0, the midline is the x-axis. So because our d, we are setting it to be 0, that is why the midline is the x-axis in this case. The local minima will be the same distance below the midline. This is the local minima, right? And now this point. Let us take it a step further. Now, how do we then find the amplitude? I will just say, I just need to find half of the maximum value, the maximum, and the minimum value. I just need to find half of that. That would be the amplitude. How tall the graph is from rest amplitude. Now, again, when A is greater than 1, when our A is greater than 1, the function is stretched vertically. Just like I showed you with x squared, when you are multiplying it by 2, by 3, then you see the y value is becoming bigger, right? So when A, or the absolute value of A, is greater than 1, the function is stretched vertically. And when it is less than 1, the function is compressed. For example, in the example I gave you for x squared, if I have 1 over 2, 1 half, compared to x squared, whatever this is, this guy will be half of it. Say my input here is 4. So 4 squared is 16. Now say my input here is 4. 4 squared is 16, and half of 16 is 8. So you can see shrinking compared to this. Okay, so that is when A is less than 1, the function shrinks. It compresses vertically. So again, this is an example when A is 1, we have this situation. When A is 1, we just have this, right? When A is 2, vertically stretched. So you can see we have this. When A is 2, it is vertically stretched. And when it is 3, when it is 4, and so on. What if it is maybe 0.5? Then it shrinks, compresses vertically. Now, we notice from just even from this, if you look at here, in this case, the amplitude now, this is the highest here, which is 1, and the least point for it, the local mean, is -1. So we can see that amplitude itself is half of the maximum minus minimum. That is, in this case, 1/2, our amplitude is 1/2 of the maximum, which is 1, minus the minimum is -1. So that is half of 1 minus 1 is 2. So that is 1. So the amplitude is 1 in that case. And we have it here. Let us consider example. What is the amplitude? What is the amplitude? What is the amplitude of the sinusoidal function? F of x equals to -4 sine x. Well, from f of x equals to -4 sine x. Amplitude, remember, we define it as amplitude will be the absolute value of A. Our A in this case is -4. So absolute value of -4 is 4. Therefore, our amplitude is 4. And as you can see from its graph, you can see that the graph is as tall as up to 4. Okay. Now let us continue to analyze graphs of various, uh, types of sine and cosine, that is variations of sine and cosine of angles. So far, we have studied how A and B relate to the general form, the amplitude, and how B relates to the period. So we discussed that extensively. We now proceed to study how C and D relate to the equation. Let us study C and D. So remember our equation one, this guy. From our equation one, we have y equals to, that is the general form for it, y equals to A sine bx minus C plus D. I'm going to do something very quickly. I say y equals to A sine. I want to pull out that B. If I pull out B, I will be left with X here. However, I need to be careful. If I put C here now, there is a problem because if I multiply this back, it will be BC, and here is not BC. So I need to divide here by B, so that when I multiply that, B times C over B, I will be having just C, as it should be. Okay, good. Now, we already studied B. We've already studied A. Now, this item here, C over B, is called a phase shift. A phase shift. And this item D, we call it vertical shift. Vertical shift. Remember, here we say this is vertical shift. Vertical shift, it could be compressed or stretched vertically. Here we call it phase shift. Here this is compression, this B compression horizontally. Why this is shifting vertically, that is compression or shifting. Maybe it shifts up or down, upward or downward. Okay. So let us look at something. So that is exactly what I have here. So we call C over B the phase shift done, or the horizontal displacement of the basic sine and cosine function. Phase shift, or the horizontal displacement, maybe shifting to right or shifting to the left. Horizontal displacement, or you can call it horizontal shift, right? From your study of transformation. Now, looking at this graph of sine of x, we can see clearly, looking at this, we see that f of x sine of x, that is not problematic again. We do know the behavior now. Now let us study this guy. Now, look at the behavior of this function. Look at the behavior of this function. The behavior of this function. Now, you will see that instead of this point to be here, it has been shifted to the right. So it is no longer here now. It is now here. That point has been shifted. Now, look at this point also. It has been shifted here. Now, we have it this way. That is that phase shift. And say it is shifted to the right. Now, do not make mistake, because this is where confusion comes for students. So let me clarify that. But this is negative. Why is it negative? And we are saying it is shifted to the right. Where? The phase shift itself, C over B, is positive, pi over 4. Remember that this negative is coming from the general form, A sine B into X minus C over B. So that negative is coming from that general form. The C over B itself, that is the phase shift itself, is positive, pi over 4. And that is why it is a shift today. The same thing if we study, let me clear this. Now let us study this other function, this function. Now we will see, let's take for example, that is where we have it behave like sine function. Is that true? We have it behave like sine function here. The other side is just, when you are now moving this way. But when we move in, when we're moving this way, but when we move counterclockwise, it starts here, right? Okay. Now, let us understand what is going on here. Again, comparing that to sine of x, we notice that instead of the graph to start here, it has been moved to this point. It is starting here. So that point has been displaced, shifted horizontally to the right. Okay, now you know what that means. By what value now? By pi, because it is, instead of it to start from 0, it is now starting from pi. So we say it has been shifted to the right by what value? Pi. So we have it here, pi. And again, the negative, as I explained, is coming from the general form. So now, what if this is plus? It tells you something, that what we have there is x minus, let's say pi. So that tells you it shifts to the left. Okay, I hope that is clear enough. Let me continue with the study of sinusoidal function. Okay, example 3. Use technology to study the following functions. Record your observations of how 2 and 3 compare with 1. Okay, so you can go to decimals, and I want you to, type sine x, then sine x minus pi over 4. When you do that, you will realize that it shifts by pi over 4 to the right. And when you do pi over 6, you will see that it shifts to, let me see if I can show you here. Let me quickly show you what I mean. Stop sharing. I will share this. Okay, let's see. Y equals to sine x. Let us again see y. Let us compare that to sine, let's say x plus pi. Let me start with minus pi over 4. Then what do we observe here? We see that our C, sine of x, is this column. Whatever that color is a blue. And this is purple, I believe. Now, if we compare the two, you will see that instead of this starting from this point, 0, 0, now we have the purple starting from here. It has been shifted It has been shifted to the right by pi over 4. Okay, the same thing, if we do, let's say y equals to sine x plus, in this case, pi over 6, then it's in black. You will see right here, right here. So instead of this starting from this point, 0, 0, it's now starting from here. So it has been shifted to the left. All right, so that is what I ask you to do by, oh no, not this, by using technology. Or you can use your graphing calculator. It is the same thing. So in general, let us conclude. In general, we say if C is greater than 0, what is C? Where's our C? Remember, y equals to A. You should know this often. A sine B x minus C plus D. So we are saying if C is positive, if this C is positive, then we have a shift to the right. In that case, you can have something like sine of x minus pi over 4, right? So we have a shift to the right because this C itself is positive. And now when C is negative, the graph shifts to the left. That is when you have something like y equals to sine x plus pi over 6. Because the general form is that it should be x minus, it should be bx minus c. So which means I can rewrite this as this form. Now you can see in this case, our c is negative. So it means it shifts to the left. Now, I don't want you to get confused. Teacher, the other time you were talking about C over B. Now you are talking about C. What is happening? Just calm down. Let me explain what is happening here. If I'm considering the general form, I can talk about C. If I rewrite the general form, I can write it like this: A sine, I pull B out, then I have x minus C over B. You will see how we will use these two situations. They are the same thing. Both of them are the same thing. Example will help us to learn them very well. The greater the value of C, the more graph is shifted. Yes, we have seen a situation when if our C is pi, then you see that it shifts to the, let's say it is shifting to the right, then it will be farther, right, from that 0 where it's supposed to start. Okay. Now, why C relates to the horizontal shift? We have studied that. It relates to horizontal shift to the right or to the left. What about D? We say D indicates the vertical shift from the midline in the general form for a sinusoidal function. I talked about that the other time. Let us look at the function sine of x plus D has its mid value at y equals to D. Now, that is the cool thing. The mid value, when D is not 0, then the midline is going to be the value of this D. Then we say y equals to D is the midline. For example, in this case, whatever our D is, let's say it is 1. So our midline is going to be here. Remember what the midline is doing. It is considered as the rest point where you start to measure the amplitude of the sinusoidal function. Okay. You can use technology again to see this, you will see how your graph jumps up, no longer staying on the rest line, just like what you have learned from transformation of, let's say, polynomials. Like if you have something like this, x squared, then you have it behaving this way, right? And then now, if you say, let's say you have something like 2, then what happens? You have it jump up like this. And if it is maybe -2, then you have it somehow behaving this way, right? So it is as simple as what you have learned in the past. Okay, now, given an equation in this form, we know the form by now. In this form, or for cosine in this form, C over B is the phase shift and D is the vertical shift. I explained that C over B is the phase shift. We will use example to see it better. Example, determine the direction and the magnitude of the phase shift. That is it shifting to the right or to the left? Okay, now in this case, look at it. The first thing is for you to study this side. Because remember, when I was showing you, it is now starting here. I was comparing it with the graph of sine x itself. So that is why you must ensure that this side, that the b is 1. If it is not 1, you need to pull it out so that whatever you have here will be your phase shift. Okay. Now, in this case, it turns out that our phase shift is minus pi over 6. How do I know it is minus pi over 6? Because the general form is y equals to a sine b x minus c over b plus d. That is what we do have. Now, because this minus here, we are having it to be plus, it means the phase shift itself is negative pi over 6. And that implies a horizontal shift. Let me just say horizontal left shift. So that is the direction. The magnitude. Oh, okay. Another way to say is the magnitude is pi over 6. That is the magnitude itself and the direction. So I can say magnitude is pi over 6. Direction. The negative is the part that is giving you direction. Direction is left shift. So depending on what the question is asking you to do. I hope that is clear. If it is not, let us take another example. But before then, pause this video and try this. Determine the direction and the magnitude of the phase shifts for this function. I hope that will be easy for you to do. Now, let us work on this example. Determine the direction and magnitude of the vertical shift. Now, vertical shift. Again, we are talking about that D part. So, the magnitude is magnitude. Okay, everything is gone. The magnitude in this case is 3. Direction is downward. How do I know? Because downward. because it is negative. So it is vertical shifts downward. Now, what about this? In this case, the magnitude is 2, and the direction is upward. So there's a vertical shift upward, that is above the midline. How that makes sense? In conclusion, given a sinusoidal function of this form, identify the midline. We know what the midline is now, this. The amplitude, this. The period. We know that the period is related to b by 2 pi divided by absolute value of d. So we can find the period. And the phase shift, well, we know the phase shift is here, but we need to be careful. Phase shift is c over b. We need to pull that b out. So in general, absolute value of a is the amplitude. The period, I talked about it. Phase shift, I talked about it. And midline, y equals to d. Now let us take example. Let us take example. Determine the midline, the amplitude, the period, and the phase shift of this function. Let us start. Midline, you know that. Let us start by saying the general form of a sinusoidal function is, you should know this in your head by now. A, in this case, we are working with cosine. So cosine, I need to say b into x minus c over b plus d. Now, my d in this case is positive 4. So midline is y equals to 4. That is vertical shift upward. Okay, the next thing, amplitude. We also know that amplitude, that is the height of that function. Amplitude is the absolute value of a. What is a? This is our a. If you compare it with this, that is a, right? So that is absolute value of 1/2, which is 1/2. Okay. Now, the next thing is the period. Period, we cannot pick it directly from the equation itself, but we do know that period is related to something in that equation, which is b. So we use absolute value of b. So that is 2 pi divided by, then let us go back. What is b? We need to do something to get our b. And that is, we can rewrite this as 1/2 cosine. Our b is 1/3. 1/3. I need to pull it out. Every time I must have x there because that is what I'm comparing it to. X. Now, minus, remember, I pulled 1/3 out. So here I should just have pi. Because if I multiply it, I must get pi over 3. Okay, so plus 4. It will not affect that because 4 is on its own. All right, now, what do we have here? Now, we do have our b here. And here now is c over b. Remember, we said this guy divided by our 1/3 here. So this is now our phase shift. But what do we need? We need b here now. So that is divided by 1/3, which is 2 pi times 3 over 1, and that is 6 pi. What does that mean? It means it takes the function 6 pi to complete one rotation. 6 pi to complete one rotation. Okay, interesting, right? And lastly, phase shift. Well, done. Phase shift. Phase shift is C over B, and it is pi. And it is a horizontal shift to the right. Again, how do we know? Since this is just pi, this is just pi. This negative is in the general equation, so it means C over B itself is positive, so it is a shift to the right. Okay, I hope that makes sense to you. I hope that makes sense to you. You can replay this part and relearn it again before you move on to the next example. Okay, determine the midline, again, the midline, the amplitude, the period, the phase shift of the function. Okay, same thing we have done. Y equals to 3 sine 2x plus 1. In this sense, we see that if we compare it to y equals to a sine b into x minus c over b plus d, we will see that we have the midline because we have this, we have the midline. So midline is y equals to 1. That is vertical shift upward because it is positive 1. So shifts upward. The next thing, amplitude. Amplitude is the absolute value of A. In this case, the absolute value, our A is 3. So absolute value of 3 is 3. So the amplitude is 3. That is the vertical height from the midline. Period. Again, we know that period is related to B by this formula. So that is 2 pi divided by B is 2. B is 2. 2. So that is pi. So the period is pi. That is, it takes just pi for that function to complete one rotation. Lastly, phase shifts. Do we have this? No, we don't. Just that means in that case, C there is 0. So we say since C equals to 0 in this case, then C over B is 0. That is the phase shift. The phase shift is 0. Put differently, there is no phase shift. And what that means is that the function is starting where it's supposed to start. Okay. The next thing we want to study now is how to determine the formula for a sinusoidal function when we have the graph. When we have the graph, we want to determine the formula for the function. How do we go about this? Again, this is not difficult at all. We just need one thing, and that is, remember, the formula is A cosine B into X minus C over B. Always remind yourself what all these things mean. Now let us find A, let us find B, let us find C over B, let us find D. Now, A is, we have the formula that amplitude is 1/2 of the maximum minus the minimum. Remember? So that is 1/2 of the maximum value here is 1. Okay. Minus the minimum value is 0. 0. Therefore, our amplitude is 1/2. We know that. We know that. Okay. Moving on, B. The question is, can we know B by itself from the graph? Nope, we cannot. But remember that B is related to the period by this formula. So let us see what is the period of this function. Remember that the period is the time taken or how long it takes for the function, for a sinusoidal function to complete one rotation. In a simple way to see that, just look at your function. The period will be the distance between two crests, two highest points, or two lowest points. In physics, they call it crest and trough, or two least points. So just take the distance between the two, or the distance between the two highest points, like that. Now, that means we can know the period here. Period is, let's see, if this place is 2 pi, it means here is pi, and it means here is 3 pi. So the distance from here to here will be 3 pi minus pi, and that is 2 pi. That is the period. It means it takes 2 periods for that function to complete one rotation. Teacher, if I use two least points, will I get the same thing? Yes. Look at this. From here to here. Here is 2 pi, here is 0. 2 pi minus 0, 2 pi. So it is still the same thing. Okay. Now that we know the period, let us see. Can we find B? Yes. Period is related to B by this. So that implies that this guy equals to 2 pi over period. Our period is 2 pi from here. So which means it is 1. That implies that B is 1. Okay, we have A, we have B. What is the next thing for us to find? Let us look at phase shift. Is there a phase shift? That is the next thing we need to ask ourselves. But it is not easy to see that. Maybe we should first look at where we have our midline. What is midline? Right? If our amplitude is 1/2, that is from 0 to here is 1/2, then definitely our midline, oh, that's not perfect. Our midline is going to behave this way. That is the halfway for that. Or just use your amplitude, 0.5. Just go there. That will be your midline. So this is y equals to d, which is 1. That is the midline. Now, we need to find phase shift. If I'm looking for cosine, look at what I have. What I should have is my vertical axis here and my horizontal axis here. What has happened? A cosine function should behave this way. It should start from here, right? And it moves this way. Okay, let's see. Is that what we have on this graph? It feels like it, if we look at it this way. Now that is not a straight line. It feels like we can have it this way, right? But there is something that is strange there. Teacher, should it not be from up? It should behave that way. We can also pick it from that. The only thing we note here is that it's going to be negative. It's going to be negative. Let me quickly remind you of something. If you have x squared, your graph behaves this way. If it is negative x squared, then your graph behaves this way. I hope you remember that. So that is what is happening in this situation. So I can say, okay, my graph behaves this way. The question is, does it start where it's supposed to start? It feels like, yes, it starts. It starts there. Then that means there is no shift. There is no shift. However, I need to account for the fact that I consider the one that is moving from the other side instead of this way. Okay. I don't want you to get confused. So what I have now, I will claim that phase shifts, phase shifts, I will claim it is 0. That is, I do not have phase shift. And I will claim that my formula y is 1/2 with a negative because of the way I have considered my equation this way. Negative 1/2 cosine b is 1, so I can just see b is 1, so I can just leave it. So x minus 0 because I claim there is no phase shift. D is half, so plus 1/2. And we can see it is a vertical shift. It is vertically shift upward, so that is fine. So conclusively, we have y equals to 1/2, negative 1/2 cosine of x plus 1/2. Let us try to graph this in decimals and see if we would have same thing. I will stop sharing this and I will share my decimals. Okay, let me clear this now. Okay, that's weird. All right. So what we have there is y equals to negative 1/2, negative 1/2 cosine of x, then plus 1/2. Look at it. Is it similar to what we have from the graph? Yes. Look at that. That is exactly what we have, right? This point is still pi comma 1 as we have from there. So you can see that means what we have done is correct. It is correct. Now, I will say this, guys. Let me go back to my notes. So you will see that what we just grabbed is exactly what we have here. Now, let me state this. Is that the only equation that we can form? No. In fact, we can form for sine and cosine. And even for cosine, this is not the only thing I can form here. This is not the only equation that will work. I can form another one. For example, if I put my vertical line here, I want to consider that there is a shift. I can put my vertical line here. Okay, look at something. It is so simple. And remember that our horizontal line, our midline is there. Guys, what do you see? In this case, we realize that, and in this case, we are looking for cosine. Now, it is behaving this way, the way it should behave, like what we have here, and what we have here, right? Starting from the top, that means it is considering the positive in that sense. Okay, let's see if we will have same results. Now let me clear this. Okay, but there is one thing you will now notice. Instead of this point here, please look at this, guys. Instead of this point to be here, I have shifted it to the left. So there is a shift in this one now. I have shifted it to the left. By what value? By 0.5. I have shifted it to the left by 0.5. Now, let us form our equation. So that is y equals to, in this case now, it will be positive positive a in this sense. How so? Because I'm starting from the top, the way cosine function should behave normally. So that is 1/2 cosine. Our b is still 1. So 1 into x minus. Now, what is the phase shift? I have shifted to the left by 0.5. And since it is to the left, that means I will have negative 0.5. Then our d is 1/2 as well. Look at what I've done here. I'm using this y equals to a cosine b into x minus c over b plus d. I know our a, we've computed a, cosine, b is 1, we find b, 1, x minus phase shift. When you look at it from the graph, what you are getting is c over b, the phase shift itself. And I have moved these points. Instead of it starting here, I'm now starting here. That means I have moved it to the left. And since it is to the left, then this is going to be negative. And conclusively, I will have 1/2 cosine 1, which I do not need to put there again. We are mature to know that it is 1 now. That is x plus 0.5 or 1/2 plus 1/2. Let us see. Let us graph this in decimals and see, maybe we will have exactly the same answer. Okay, I will stop sharing this and go to my decimals. Here. Okay. Y equals to, in this case now, I consider positive cosine. I have a phase shift now, which is plus, yeah, 1/2, I believe. Then I have a vertical shift upward of 1/2. Oh, there is, let me see, what do I have? My notes, my notes, my notes. It should be the same thing. So let me quickly check what I have. 1/2. Okay, cosine of x. So we shift to the left, so that is 0.5, and we moved up 1/2. All right. Oh, sorry, guys. There's a mistake with what I used here, not 0.5. Um, oh, let me share this. Stop sharing. When I am, I will share this, yes, instead. Okay, guys, here, remember I have my vertical line here. Now, here is, I have shifted it with, sorry, I was using this, that is y value. Here is 2 pi, so from here to here should be pi. So that is negative pi. So negative pi. So that place should be positive pi now. So positive pi. Okay, now let's see. I will stop sharing this and go back to my graph. Okay, so here I will change this to pi. Okay, it's the same thing. You can see it swallowed that graph. Is it still there? Yes, if I click on this, I have, let me remove this. If I remove this, I have my reg, right? That means they are the same thing. Now they overlap. If I close both of them, I don't have anything. If I open this, I have the graph. If I I open this, they overlap. So that means they are the same thing. Okay. Let me go back to my notes now. Now we have learned that all what we need to do is to ensure that we do the right thing. There are so many equations that will lead to that same function. Okay, I hope that makes sense to us. Let us solve, I believe, maybe one more. One more. Okay, I have tried, then one more example. Okay, so let us do this. Determine an equation for the sinusoidal function in the figure below. Now, in this case, we were not told, like here, when we have to write it in cosine. In this situation, we're not told if it is cosine or sine. So we are free to use anything, and it will be the same thing. If student A writes theirs in cosine and student B writes theirs in sine, if you graph it, you will have the same thing. Okay, again, let us start. The midline, well, this is the halfway to that function. See, it divides it into two at that point. If you cannot do that, just find your amplitude, which is, anyways, you are still going to find it. Amplitude, which is halfway of the maximum, which is 1. The maximum is 1. The local max is 1 minus the local mean is -5 minus 5. And that is 1/2 of 6 and that is 3. That's so 3. Yes, so that is 3. And now, how do we do that? If you are starting from this point, so look at it, 1, 2, 3. Or if you are starting from this point, so 1, 2, 3. So that is how you will know that is where your midline is. So in this sense, I will just write y equals to -2. That is our midline, or that is our D. We find D. We know our amplitude now. Okay, what do we need next? Remember, our general formula is A sine B into X minus C over B plus D. We know A, we know D. Let us find B. Now, how do we find B? We know that period is related to B by 2 pi over D. So we can find B by saying 2 pi divided by period. Now, but we don't know period. However, remember, we can find period. So let us find period. Let us find period. That is P. Period is, again, just use the distance between two highest points or two least points. In this case, I will just consider these two least points. What is the distance between the two? Here seems to be 4. So that is 4 minus, and this place seems to be -2. So -2, and the answer is 6. So the period is 6. Now, B is 2 pi divided by 6. And that is, I can do 2 year 1, 2 year 3. So our answer there is pi over 3. We know B. We know B. We have A, we have B, we have D. Now we are left with the phase angle. We are left with the phase angle. How can we do this phase angle? It is very simple. Just think about it. This is how sine graphs behave. A sine graph will start from this point, from 0, and move there. Now go to your midline. Go to your midline. Okay? Go and construct a vertical line where you know that it will be easy for you to get sine. Let me look for one. Okay, I can do this place. I can do this place. Let me show you. Here. That is not a good straight line. I can use this place. Does it mean, teacher, I can use any place? Yes, you can use any spot on that place. I will tell you why I'm picking this. Look at the behavior of sine. It must start from rest, from that rest point. And I want it to start from the rest point. Okay? Now, you would see that instead of that rest point to start from here, it is now shifted here. That means there is a left shift. I have a left shift. By what? Now, we go to our x value. From here to here is -1. So here, I can say that is -0.5. -0.5, give or take. Now, is it behaving as a sine function? Yes, it is. Look at it. It's behaving as a sine function. And so on. Okay. Now, we have our phase shifts. Phase shifts. phase shift to the left, to the left, to the left. So that means our phase shift is what? I claim it is -1/2. Again, let's be careful. Are we picking x values? Yes. So now, do we have everything? Seems so. Let us bring everything together now. Therefore, y equals to, and remember, my amplitude is going to be positive because I am moving this way. That is the way sine should move. If I have considered something like this, then my a will be negative because there's a reflection. Now, that is, my amplitude is 3, I believe, 3 sine. I'm just using this formula. My amplitude is 3, so I put it there. Sine b is pi over 3 into x. Where do I have x? I have it here from the formula. Let me rewrite the formula here. Y equals to a sine. This should be in your head. It should be in your head. C over b plus d. Okay, so x minus, there is a phase shift as we find it to be -half. So -half. And our d, we find our d to be -2. No. So -2. Definitely here now becomes, I can say this becomes plus. So we have it. Let us go to decimals and see what we have. 3 sine pi over 3x plus 1 over 2 minus 2. Let us go to decimals and put that same function here. Y equals to 3 sine sine pi over 3 into that is not okay. I will do pi over 3, then I'm multiplying that by x. We have plus there, I believe, plus 1 over 2, I believe. Then I'm going to shift everything here to look at that. Oh, let me close this. Look at that. Beautiful, right? So we have same thing. We have same thing. You can check. You can check like what is the value there, 1, 1. What is the value is that is let me move this upward. The value here, -2, -5. So we have the same thing. If you create that same equation using, let's say, cosine, you will get that same graph in decimals. So that is that. I know this is a lot. You can replay the two examples and use that idea to find it. So you are not restricted to how you can find it. So here, you want to find sine. Find sine. In fact, you can go ahead and even find cosine for it and graph it in decimals. Once you have something like this, that is how to know you are correct, at least to help you practice. So you do that, and you also try this. Determine an equation for the sinusoidal function in the figure below. So also for this, they are very simple. Lastly, for today, I want to graph I want to graph. So let me consider the last example. Given y is this, now we have equation. We want to move to graphing it. Okay. Now, let us see if we will be able to do that. Y equals to -2 cosine pi over 2x plus pi plus 3. Let us identify the various parts we have. This is A. This is not well written, so before I identify it, I will write it in the proper general form. -2. What I mean by that is I want to pull out B. So B is pi over 2. I pull it out. I have x left here. Plus, now I need to be careful. I will say here is 2. Let's see. Pi over 2 times 2 is pi, which is what I had there originally. So you need to know how to factor that out. So plus 3. Now here I claim I have A, here I have B, here I have C over B, that is the phase shift, and here I have D. Now let us graph. Can we graph? Are we ready to graph? Maybe, maybe not. Okay, all right, amplitude. Amplitude, the question says we should find amplitude and all those guys. So amplitude is absolute value of A, which is absolute value of -2, and it is 2. Then we want to find period. We remember that period is related to this B using this. And now that is 2 pi divided by our B is pi over 2, pi over 2. So which is 2 pi times 2 over pi. So that is 4. What does that mean? It means it takes 4 point values. Let me just put it that way to complete one revolution. 4 to complete one rotation. Let me keep it at rotation. Okay. Phase shifts. We say our phase shifts is 2. Now, look at this. +2. Remember the general form. The general form is this. Y equals to A cosine, B into X minus C over B plus D. It should be minus. Now we have plus. So that means our phase shift is negative, meaning left shift. That is what we are, left shift. Another thing we need to take note is this negative. Now, what that means is that since this is the way cosine behaves, since we have negative there, it means our behavior should be something like this. How that makes sense? Okay. Now, lastly, midline. Midline is D. Is D, which implies that Y equals to 3. That is shifted vertically upward. So that is what we mean here by vertical shift upward. Now, let us draw our graph. Maybe we will be able to do that. We do this. We do this. Okay. The first thing you need to do is the midline. Our midline is 3. Let me make this guy here longer. Okay, let me say this is 1, 2, 3. So, no, I don't want that. Okay, okay. So that is my midline, the rest line for my function. That is 3. 1, 2, 3. Okay. Let me call here 1, 2, 3, 4, and here -1, -2, -3. Here -1, -2, -3. Now this midline, that is where my graph is at. My function is divided into 2, right? Now, what is the amplitude? Our amplitude is 2. I just need to count here. 1, 2. So 5. Then 1, 2. That means this is the local max. This is the local min. Or like the highest and the least. Let me put it that way. Okay. Now, what is the next thing that we can use in this case? We know the behavior of cosine. It should start from here. Oh, it should start from there and behave this way, behave this way. But because of the negative we are having here, it has to start from somewhere here. But now, there is one more thing we need to consider, the phase shift. Meaning it is not starting on this normal vertical line. It has shifted to the left. How beautiful, right? So shifted 2 points, 1, 2 here. So that means our vertical line is somewhere here. Okay, now let us see. Remember, now we are starting at this point now, right? We are starting at this point. Instead of here, it has shifted. So we are starting here now. And we have to go this way because of that negative with the amplitude. Now, the last thing I need to explain is this. Remember that the period is 4. The period is 4. What does that mean? How does that help us? Well, it tells us that it completes one rotation. It completes one rotation. 4 steps. Complete one rotation. Let me put it that way. Here, let's see. We have 1, 0. Here we have 0, 1. Here we have -1, 0. Here we have 0, -1. Now, our graph is going to start from somewhere here, right? So that means we are starting from this side. How that makes sense? From the negative parts. Now, remember the period is 4. So that means I need 1, 2. Please follow me, guys. From this line now, I need 1, 2, 3, 4. That is where I will complete my one rotation. I hope that makes sense. Now, at this point, I'm starting here because that is where the height reached. Now, at -1, remember, I will move on to 0. So I will be at 0 point here. I hope you are following. Now, I will move to the highest point. At the next point here, I will move to the highest point. And the highest point is here. Now, the next one, I will be back. Oh, sorry, the y value there. I will back to 0. So that is here. I will be back here. And finally, I will move on to here. So that means at this point now, I will be here. That is the lists. I'll be back to the lists. I hope 1, 2, 3, 4. So I move from here, move to when it is 0, move to the highest point, then back to 0, then to the least point. So it turns out that my graph should be this way. This place is not curved very well, but yeah, something like that. So that is one full rotation of that function. That is one full rotation. Remember, it's a cosine graph, so that is the behavior. I hope this is clear to you. It is fun, I believe. So the most important part in this problem is you identifying the period and divide it into 4. Divide it into 4. Okay? So when you divide it into 4, then you just move. You know that the first, it will start from the highest or the least for cosine in this case. Then it moves to, just look at this, right? Starting from the highest, then to 0, then to the least, then back to 0, and then the highest. That's the same thing we have done here. So starting from this point, which is the highest now, but inverted way, right? Reflected. Now going to 0, then the highest, which is supposed to be the least, but now becoming the highest here. Now back to 0 as we have it here, then back to the highest here, which in this case will be the least. So, and this part is also important. It tells us the behavior of the graph, if it is reflected or not. Because if this place is positive, then we should have something like this. That is the only thing that will be different in that problem. So, guys, this is where I'm going to be ending this video. I hope this video makes sense. We covered a lot. I will advise that you take your time to go over it very well and before my next lesson. So, I will be stopping here for today. Thank you for staying to the end. Don't forget, you can share this video or you can, send it to someone you know can benefit from it. So, till I see you again, bye for now.